So we're starting with chapter 9. Chapter 9 is about hypothesis tests, and we require you to be able to set up the null and alternative hypothesis. For this textbook, all the null hypotheses will set as equal. Okay? And the alternative have three types. If it's less than, so if you think about the bell curve, your mean is in the middle, right? If less than is all the small numbers, so it will be left-tilted. If it's greater than, it will be on the right-hand side with all the big number, so it will be right-tilted. If it's not equal to, it will be the two-tailed. So it has three types for the alternative hypothesis. So we did some example, and you will see some questions like this on the test to ask you to set the null hypothesis and the alternative hypothesis, okay? And what else is in chapter 9? Chapter 9 also talk about there are two possible outcomes of hypothesis test. The two possible outcomes for hypothesis test will be reject the null hypothesis or not reject the null hypothesis. So I could have exam question list a lot of different outcomes and ask you which one seems to be like a plausible outcome for hypothesis test. So we only have two outcomes for hypothesis test, either reject or not reject the null hypothesis. So if you see something like accepting the null hypothesis is not possible. So we talk about how do we decide that. And toward the end, we also decide if something is statistical significant. What value do we use to decide if something is statistical significant? What value do we use to decide if something is statistical significant?
The p-value.
The p-value. So the key concept here, if the p-value is less than the significant level, so then it would reject the null hypothesis and it is significant. So that's the only major thing here. So we did an example with a p number like that. So we can see if we convert it to percentage, it seems to be bigger than 0.011%, but smaller than 0.055%, right? So again, we say if the p-value is less than the significant level, we do what? Reject the null hypothesis. Is it significant or not significant? Significant. So for this particular example, 2.28% for the p-value is bigger than 1%. So do we reject the null hypothesis? If it's bigger than the significant level, do we reject null hypothesis? No. Is it significant? No. Is smaller than 5%, so the p-value is smaller than 5%, so at the significant level of 0.05, do we reject the null hypothesis? Yes. Is it statistical significant? Yes. So I may have exam questions like that with fill in the blank, give you the p-value, give you the significant level, and ask you, do you reject the null hypothesis or not reject the null hypothesis, and ask you if it's statistical significant or not statistical significant. Are we okay with that? So if you missed chapter 9, that lesson, you need to watch that lesson online and take notes, okay? We did other example, and then we talk about error. So if you missed that, get the blank handout for me, and make sure you watch this video online. We're getting very close to be done with this semester, so looking at the handout I gave you here, so the last three questions is related to chapter 9. If we look at that, they ask you to set the null hypothesis and the alternative hypothesis, right? So for the first one, the medical researcher wants to test the claim that the healthy adult have a mean body temperature of less than 98.6 degrees. So the null hypothesis is H0, the alternative is HA. This is the handout I gave you today on the back, the very last part. This is for chapter 9. And for this one, I told you the null hypothesis is always set what? Equal to. So what do I put here? the mu, the population mean. The population mean is equal to 98.6 degree Fahrenheit. So the alternative is what? Less than 98.6 degree. So remember the bell curve. If it's less than, the mu is here. Less than mean the number is small or big. Less than the mean will be on which side? On the left hand side, like here, right? So this would be left-tilted. Are we okay? How about number 16? A medical researcher wants to test the claim that healthy adults have a mean body temperature difference from this, which means the null hypothesis, we are going to set the population mean is equal to 98.6 degree, always equal, right? How about the alternative? Not equal to, so if it's different, right? So not equal to 98.6 degrees. So if it's not equal to, it would be what tilted? Two tilted, because the mu here, if it's not equal, is both sides, right? So two tilted hypothesis test. Are we okay? The bottom one, the quality control manager at the manufacturing company claimed that the proportion of defective transistors is greater than 0.03. So what do? The null hypothesis would be equal to 0.03, and then the alternative greater than. So if it's greater than, what side of the graph would that be? On the right hand side, so this would be right tilted. Are we okay? So the other concept I told you, there's two possible outcomes for hypothesis test. What are the two? Either reject the null hypothesis or not reject the null hypothesis. Only two, right? So if I list a bunch of them, you need to pick out the correct one for me. And the other one is, how do we test the significant level? I mean, significant or not? We use the p-value compared to what? Either sometime would be 0.05 significant level, sometimes it's 0.01 significant level, right? So I give you a number which is 0.07. Is it significant for 0.05? Is it bigger or smaller? My 0.07 is bigger, so do we reject the null hypothesis? No. Okay, when you don't reject the null hypothesis, is it significant? No. Okay. Of course, if it's not significant for 0.05, for 0.01 would be, do you reject? No. Okay, if you don't reject, is it significant? No. Okay, how about if I have 0.002? So, is this smaller than 0.05? Yes. Do we reject the null hypothesis? Yes. Is it significant? Yes. Okay. How about compared to 0.01? Is this smaller? Yes. Do we reject the null hypothesis? Yes. Is it significant? Yes. So when the p-value is super tiny compared to the significant level, you reject the null hypothesis and it is statistical significant. Is it okay? So you're going to need to practice. Some of you missed that class. Okay, so let's move on to chapter 8. What's on chapter 8? So chapter 8 is about sample distributions. Basically, they say when your sample size is bigger and bigger, the sample mean will almost match the population means. And it will form like a bell curve normal distributions, right? We talk about the proportion, sample proportion, and then we also need to calculate the margin of error in this section, right? So we figure out how to calculate the margin of error, and using that number, we also form this, right? What is this? The confidence interval for the population means, using the mean, subtracting the error, and adding the error, right? So we kind of did something like this in chapter 1, but this time we also calculate the error. In chapter 1, they just give you the error. Okay, so beside that, we also try to calculate depending on how big is the error. Then you need to figure out at least how big your sample size need to be. So there's some calculation in chapter 8, right? So let's do some example together. So on your handout, I think the one right on top of chapter 9 is from chapter 8. So the 13 and 17 are from your chapter 8 questions. One of them talk about margin of error and confidence intervals, assuming that population means are to be estimates from the sample described. In each case, use the sample results to approximate the margin of error and 95% confidence interval. So using number 13, we're going to need to calculate something, right? So what are the formula? So we're going to need the formula of what? Formula to calculate the error. So number 13 is from chapter 8. So chapter 8, we talk about the error. So what is the formula for calculating error? We have 1.96 times the standard deviation divided by square root of sample size. Perfect. So my n equal to, which is for this question, 100. And my sample mean, they will use that as the population mean, right? They say, so the bar x, which is the same as I'm sorry, this one is the samples. Standard deviation. Standard deviation is what? 5.0 cm. And just plug it in, right? That's all we need. So 1.96, my standard deviation is 5.0 divided by square root of 100 with my sample size, right? 0.98. So for this particular one, I think they round it to a whole number. We will tell you on the exam, okay? So they say the error is 1.0 centimeter. So earlier when I was talking about it, I almost did the common mistake that a lot of people do, is plugging into the wrong number there. So using that is my error, right? How do I form that 95% confidence level? I will put the mean in the middle. And one side, I need to use the mean and do what? Subtract the 1. So what is my mean? 55, subtract the error. And then using the mean and add the error, right? So 55 add 1. So it's going to be between what? 54 centimeter, and then the mean, and then 56 centimeter. Is that okay? Question on this. So from chapter 8 example, we will have question that asks you to find the error. Just make sure you plug it in correctly, because a lot of students plug it in incorrectly on the test. So standard deviation here, sample size here, and when you need to find a 95% confidence interval, you use the mean, subtract the error, mean, add the error. Is that okay? So that would be the answer also. Question on that. Okay, how about number 17 here? So this one you need to find the sample size, assuming that you want to have to construct a 95% confidence interval. Estimate a population mean. Found an estimate of minimal sample size needed to obtain the specific margin of error for a 95% confidence interval. The standard deviation is given. So margin of error is 2.6 minutes. Sample standard deviation is 45.4 minutes. They want to find the minimum sample size needed. Okay, so this is also from chapter 8. This is number 17 here. So for this one, number 17, I'm going to need to find the minimum at least sample size need to be? What is the formula? 1.96 times the standard deviation divided by error square. Okay, don't forget the square. That's another common mistake, okay? Alright, so this one, help me to plug it in. What do we have? 1.96, what is my standard deviation? 45.4 minutes divided by error is 2.6 minutes. Okay, somebody have the answer. Don't forget to square, okay? What do we get? 11.1171.3 something, right? Okay, so remember this is at least the sample size, so we should always round it up or down, because this answer would be at least this number or bigger. So I need to round this up always for the sample size, okay? Okay, so I should make the answer to be 1172. This is minutes. So this is at least the sample size, so you want to make a bigger number as long as it's more than 1171. Question. So far we did some example from chapter 9. A lot of you were not here last time with chapter 9. Make sure you watch the video, because I only have one question on the review, but I will have more on the exams, like what we talk about. So chapter 9, we just did setting up the null and alternative hypothesis. You also need to know the two outcome, which is what again? Reject what? The null hypothesis, or not reject the null hypothesis, and then checking the significant level with the p-value. So those are the three things will be on the test from chapter 9, okay? All right, in chapter 8, you need to make sure you know how to calculate the error and found the, at minimum, at least the sample size need to be how big, okay? All right, so that is chapter 8.